my fellow panelists have already shared how AI can help manage IAQ risks. What I'm going to do is I'm going to draw from my experience. I'll take a few case scenarios and I'll try to showcase how AI could enhance the decision making. It could enhance the quality of insights in those scenarios through actual outputs from an AI tool that we use. But before that, just to take a step back, it's important to understand, as my fellow panelists have also mentioned, that IAQ is a multi-dimensional construct. When we talk about outdoor air, we talk about AQI, and in Indian context, AQI is predominantly PM2.5. But when we step indoors, the scope of indoor air quality expands. It's not just PM2.5, it's also PM1, as Ashutosh mentioned. It's VOCs, it's molds, pathogens. And for example, you can't just close your room down, switch on an air purifier, and sit there because CO2 will start building up and it's going to impact your health as well. So CO2 is also important. And while we are solving this, we need to keep in mind the energy cost, the thermal comfort, the humidity. We cannot just put 20 air purifiers in a room. We will have clean room grade air, but the cost of running that and the practicality of that solution is not really good. While we also want to avoid unwanted emissions like ozone, chemicals, etc. If we can sense the air quality issues, it's already too late. And that's why we need to rely on the tools that we already have. There are enough low-cost monitors that are available today. We could get these monitors for fairly low cost, where we can sense the PM2.5 level, the VOC level, the CO2 level in our indoor space without having to wait until it starts damaging our health. We also have enough air quality improvement solutions available in the market. In fact, we have way too many of those. There are filters of different grade available. There are electronic air cleaners. There are fresh air systems. There are standalone air purifiers, and also UV systems, if that's what the target problem is. But because this universe is so vast, because the data points are so technical in nature, we do need an interpreter which can simplify things down for us. And that's the role which AI can play. It can be an expert assistant that is translating this data that we get from these low-cost monitors into actionable steps. And if it can do it proactively, then that's going to help us detect well, then analyze our data well, apply the right kind of solution, and maintain our systems afterwards. Maintenance is one aspect which is often forgotten. After we apply the solution, we do need to take care of the solution. We do need to take care of the system that we have installed so that the efficiency of the system stays at par all the time. So yeah, let's just step into those situations that I mentioned. Some of these are based on the actual situation we have faced with our clients in different parts of the world. So this, for example, let me break this down. This is a scenario of an office building where we want to apply indoor air quality monitors. And it is important to know where exactly to apply them, because depending on where we are measuring the air quality, the numbers that we get could be representing the microclimate of that area, or it could be representative of the whole floor. Now, in this case, I gave this image to our AI tool, and I put 3 red dots, and I asked it, can you analyze if these are the right spots to put these monitors? And AI now is good enough, if trained well, to tell us where exactly, or what exactly is the problem with these things. For example, the one on the far left is sitting in a meeting room, which could have its own fan coil unit-based HVAC system. And it's got a different HVAC zone, which is what the AI is telling me, that this may be an FCU-based HVAC system inside the meeting room, which is not going to be representative of the whole office. The one in the middle is sitting too close to a printer, for example, and printers are known to emit PM1 when in operation. So this is going to shoot up the PM2.5 reading massively whenever the printer is in operation. In addition to that, there's also a diffuser sitting right above it. And the AI can detect that through the picture and tell me the situation. It can also give us inputs on where exactly to put these monitors. Now, the AI, there are well-defined standards, issued by institutions as well, which tell us where exactly to put air quality monitors. And AI can help guide us based on pictures of the office space or indoor space to tell us where exactly to put these monitors for good monitoring. Taking a step further, once we have the data, how do we interpret the data? Because the same PM 2.5 level reading could indicate multiple different things. And I did a very rudimentary data capture from my own apartment, from the living room, and I gave it to AI, the graph to AI, and asked it to figure out what's going on here, because most of the day, the air quality is pretty good, PM 2.5 is pretty good, but then it spikes suddenly 2 to 3 times a day. And it can identify what the problem is if it's way too obvious. If it's not obvious, of course, it will ask for more data points, but it can identify in this case, for example, cooking is the culprit, because whenever oil during cooking reaches smoke point, it releases a burst of PM 2.5. And these are not really suspended oil particles. These are burnt oil particles, which are carcinogenic as per research. So this is not a kind of PM 2.5 we want in the air. So it is suggesting me the fixes, which are quite useful for a residential sort of an environment, that you could run your range hood for longer. You could use a HEPA filter-based purifier right next to the kitchen so that it creates a sort of a air barrier while also cleaning the air from the kitchen. Use a different kind of cooking, of course, if that's possible. And if outdoor air is clean, you could consider opening the window, which was possible in this case in Hong Kong, but it's not going to be always possible. The third situation is for a classroom setting. This is one of the, again, a customer situation that we have faced in the classroom, and without getting into too much detail of the ventilation setup with EFMs, etc. The point simply was that we had the monitoring data, and there was a complaint of poor air quality, and we were asked if improving or upgrading the filter would solve the problem. But in this case, AI is able to interpret the data, and it's able to tell me that while this classroom is closed, the PM 2.5 is good, which means the filters are working well, the fresh air unit, the TFA is working well. But then whenever the door is opened, which happens during the class time, there's a backdraft happening through the exhaust vent, the door air comes in through the door, it goes out through the vent, and it creates the air coming in from the TFA gets short-circuited, it goes out from somewhere else, which is not where the air quality monitor is positioned. And all of this analysis is possible if you have a time series data point and enough information about the ventilation layout of the room. In this case, upgrading the filtration in the HVAC was not the solution, because this is not going to solve the problem when the door opens and the positive pressure setup goes in for a toss. Upgrading filtration will not fix it. So this is, again, a place where AI could objectively analyze the data and tell us whether the solution we are considering is going to be effective or not. And then lastly, for the fourth situation, first, maintenance is an extremely important parameter, which is often overlooked, because when we apply a solution, and we've seen this with our customers as well, once the solution is applied, for the first month, everyone is watching the improvement in air quality, but then after that, it takes a backseat because it becomes the job of the facility management team. And then slowly, if the maintenance is not done well, if filters are not cleaned or replaced on time, then there is going to be a problem. The air quality will start worsening, the air flow rate will slow down, the thermal comfort will go for a toss, the energy consumption will go high, and then people will start wondering what went wrong. So this, for example, in this case, I used a tool that we have developed, and I welcome you to scan this QR code to try it on your own. The idea is very simple here. The HVAC coils in any HVAC system sit after the filters. And whatever is the state of coil is the state of air, what you're breathing. So If the coils are dirty, which in this case it is, and I have seen worse coils than these. So if the coils are dirty, it tells me that A, it has become bioreservoir of mold, bacteria, which is and it's constantly releasing spores in the air, which the occupants are breathing, and it's causing the sick building syndrome. And B, it's also leading to poor energy efficiency because the heat transfer is not proper, the cooling system is not working really well, and there would be energy loss. And there are enough studies done in research which tell us what exactly is the kind of energy loss we will experience. So what we did was we took the research outputs in terms of the energy loss that happens. We took the theoretical models in terms of for a certain level of fouling with the heat transfer coefficient of these type of contaminants, what would be the energy inefficiency? And we coded it with the help of AI into a tool. So what it does is it takes a picture. You can upload a picture of your coil, and you will see what the energy loss, what's the level of biofilm and dust building up. And so it tells you what the risk and the actual situation is of the coils and of the indoor space. So yeah, I mean to sum up, it's the conclusion is the same. The AI has the potential to make the invisible visible, and not just visible but also comprehensible. It can simplify the air quality management by breaking down the problem into actionable insights, and which is what we need. You don't need to know that the PM 2.5 is poor. What we need to know is what can I do about it to fix it. So yeah, that's it from me. Thank you everyone for listening to me.